I just spent the last 30 minutes teaching this just to realize my phone only recorded half of it, and then I had to delete it to make space to make another recording, because apparently my phone was out of storage. So I'm just going insane. So I'm gonna start this off very fast. I'm gonna roll through it really fast. We're talking about circle vocab in this one, and yes, I'm gonna hold my notes in my hand. That way I can do this faster. Last time I didn't do that, but man, I want to do this fast. First of all, let's start it off. A circle. A circle is the set of points. What does it even say? A set of points equidistant from a given point, the center. By the way, if this center is called, let's say, point A, the circle is called circle A, because that's what the central point is called. So I know this doesn't really look like a circle, but if it was an actual circle, each point would be equal distance from the middle, no matter which direction you go. That might not be very true for this circle because I didn't draw it very well. That's circle. Let's move on to the next one. Let's go on to radius. A radius is just half the distance of across a circle. Across a circle, this all the way across, 180 degrees, straight across the middle of a circle is called your diameter. Half of your diameter is called a radius. Let's go over that one more time. This is diameter. Right. I might have spelled that wrong. Let me check real quick. No, I spelled that right. I have dyslexia, so if I spell it wrong, you shouldn't have asked me for spelling. This is called a radius. Half of the diameter. Cool? Let's move on. Pretty simple so far. I just want to roll through this, mate. I'm so annoyed. I'm so annoyed. Moving on. Chord. Chord is just a segment with endpoints on the circle. On the circle means on this line of the outer side. So let's say I have a point right there. I have a point right there. Let's connect those with a line. That is a chord. Spell that. C-H-O-R-D. Again, I have dyslexia. If I spelled that wrong, do not blame me. But I spelled that right. Let's go. Let's call it. It doesn't matter what the points are called. Whatever. Actually, does it say? It doesn't say how to write a chord. Next up, secant. Secant is very similar to a chord. Basically the exact same thing. The only difference between it and a chord is that the line moves through the endpoints. It never stops. It is an actual line. Spelled secant. S-E-C-A-N-T. And I know I spelled that right because it's on the sheet right there. Secant. Pretty simple. Let's keep moving. Let's keep this rolling. Okay, next up, tangent. Tangent is just if you have a single point on the circle and it has a line that moves through that. A tangent is 3 points. This is called a tangent. This line, it touches one singular point of the outer edge of a circle. This point where it touches is called the point of tangency. Cool, let's keep going. See something I'm missing here so far? No, looks like we are done with the first page. That went pretty fast, didn't it? Let me make sure. Okay, you're still there. Sorry, just had to check something real quick. Now moving on to angles. Angles are signified by this little thing right there. See that? That signifies that it is an angle. You put that before you write it. Okay, you ready? We're starting off with central angle. Pretty much in the name, it is just an angle that's connected to that central point in the middle. So this Central angles. Central angles have 3 points. This, by the way, this point right here in the middle, it's called a vertex. Remember that. It's a very important word. Let's call this point A, point B, and point C. When you write this down in the box that the teacher will probably give you, even if they don't give you a box, just write it down on your paper or wherever you're supposed to write the answer. That central angle is written by having whichever point you want to start with, whether it be A or C, it does not matter which way you go. It only matters that the vertex is in the middle of those 3 letters, such as A, B, C. You could also put the exact opposite and say, I wanted to put C, B, A. Exact same thing. Does not change. This fell off. Okay. That's central angles. Very simple. Moving on. Let's move on to inscribed angles. Inscribed angles are basically the same thing in terms of the way you put them in the answer sheet and the fact that they're an angle. The only difference is that instead of starting from the center of the circle, they start way on the other side of a circle. It is still 3 points that create an angle. This is called an inscribed angle. Spelled that right? Think so. Now let's call this point A, let's call this point B, and let's call this point C. You would write this down. Remember, A goes in the middle when you write it down because it is the vertex. Let's keep going like this. You would write it as C, A, B, or you could write it as B, A, C. I know that doesn't really look like an A, but it's an A. There, does that help? I don't know. After this, we are going on and moving on to arcs. Arcs are cool. This is the section. That shouldn't be too much fun. Arc. Not arc like Noah's Ark, but arc as spelled like this, not with the K, which is a big boat with all the animals and all the stuff that was on it that God flooded the earth. Arc. A-R-C. An arc is a portion of the edge of the circle defined by 2 endpoints. Where's my red marker? I had a red marker and everything. See, I was prepared, but I'm just too annoyed. I'm too annoyed. An arc is signified by 2 endpoints. Not always, but we'll get to that. This, it follows the outer edge of the circle. That is an arc. Get it? Okay, cool. Now, let's get on with it. We now have major arcs and minor arcs. We'll start it off with minor arcs. Remember that thing about the diameter? It cuts the circle in half, basically. Now, we are doing minor arcs. Imagine there's an S under. I don't know what the minor arc. I'm only doing one example, so better listen up. Minor arc is just less than 180 degrees. If you remember, a straight line is 180 degrees, so it is just less than that. Like here to here is a minor arc. It is signified by 2 endpoints. Let's call this point A. Let's call this point B. You would write it by putting A, B, with a little line over it, like a little half circle right there. Okay. That's minor arcs. Let's move on to major arcs. Major arcs are more than 180 degrees. Let's use my blue marker. This would be a major arc. Remember that thing that I was saying, though, that it's not always signified by 2 endpoints? This is what I'm talking about. For a major arc, it is signified by 3 endpoints. Let's call this point A, let's call this point B, and let's call this point C, right? It's the exact same thing as we were saying before. Put B in the middle. Always put it in the middle, okay? Whichever, these 2 letters, whichever one you start with, it doesn't matter, as long as B is the one in the middle. Whichever is in the middle of the 2 endpoints that you're starting with. or starting or ending, right? So like A, B, C, or C, B, A. Do not forget to put that little half moon thing over it. That is a major arc. Now we are done with major arc. We can move on to semicircle. Be right back in my circle here. Oh, that was actually, it's not a perfect circle, but that's not bad. That's not bad. Okay, now that we're moving on, semicircle. Just put that diameter back across the middle of it. That's not really the middle, but just imagine I put it in the middle, or I had started with putting it in the middle, but I didn't do that, but just use your imagination. I don't care. Here we go. It is signified with the use of 3 endpoints. 1, 2, 3. Let's call it A, B, and E. See, you thought I was going to say C, but I didn't. I switched it up this time. Now, you signified the exact same way. You write everything the exact same way, but I bet your burning question on your mind is, why does it, if it's going to be 180 degrees, no matter which way I go, why can't I just put 2 endpoints? Why can't I just say A, E? Well, it's to signify whichever direction you're going, because there's 2 directions that you could go, even if it's 180 degrees. You say the B or the E just to signify which way. You say the B, or let's say we have down here D, just to signify which way you're going, right? In this case, we would be going up. See what I mean? Oh, and you could also write this like E, B, A. I hope you understand that by now. Moving on, we're going to solve for area of a circle now. Whew. Okay, area. Formula A equals pi r squared. Give me a second. Okay, we're still good here. Pi r squared, r being radius. Okay, let's say we have our central angle right here, and our radius is whatever, 5 inches. Let's say it's 5 inches is our radius. Let's plug that number in. So put parentheses around wherever you're plugging it in. Here, square it, and pi. The first thing you will do is square that number. Square that number. Square, not that number, but square the number in the parentheses. This equals 25, because 5 times 5 is 25. And now you will get pi times 25. Get your calculator and plug that in. I'm going to be using pi on the calculator, not 3.14. So if you use 3.14, your number might be slightly different, but overall it should be about the same. Okay, so put 25 times pi, or pi times 25, doesn't matter, as long as those 2 numbers are involved and are multiplying against each other. Okay, here we go. You should get 78.54, and you might be wondering, some of you might be wondering, wait, but mine says 5.3. Why would I put 5.4? Because you are rounding to the nearest hundredth place. Round up. Okay, and remember, very, very important, never forget to put your measurement. This is 78.54 inches squared. Not just inches squared, because you are solving for a literal linear, not just a straight line. Right? Okay. You still don't fully understand that? Just rewind. I would normally give another example. In fact, in my other one I gave 3 examples, but I can't believe I spent 30 minutes and for half of it I wasn't even recording anything. Okay, but if you're still confused, rewind that. Get it back. The main thing is to remember that your formula is pi r squared. If you can remember that, you could plug it into your calculator. Your calculator will do the work for you. Okay, moving on to circumference. By the way, circumference. I know some of you might already know that. I didn't know that. I've been spelling it wrong for a while. Now, on here, it says to do circumference equals 2 pi r. I'm not going to do that. I don't like doing it that way. You can do that way. It's fine if you want to do it that way. You'll still get the right answer. But I just like skipping a step and making it simpler by just going pi diameter. Let me explain here. At a central angle right here. Cut all the way across. Let's say your diameter is, give me a unit of measurement, meters. Thank you to whoever said that. Now, 10 meters is our diameter. It's very simple. 10 times pi. That's it. That's it. That's it. That's how you get your circumference. That's easy. I'm plugging my calculator for poops and giggles, even though it's 3.14, so you should get 31.4, but just make sure. Yeah, 31.42. Never forget your unit of measurement, meters. That does not look like meters. You don't have to put the squared for this one because you are solving for a straight line that just wraps around. Okay. Just knocked over some stuff here, but moving on from circumference, and I'll pick up what I just knocked over. We're now moving on to arc length. Arc length, very simple. That stands for arc length. You might say, isn't that just a cursive L? No. Okay, arc length is 300 divided by 360 x times circumference. And you might be, what's x? X is arc length. Or, well, the degree of the arc, not arc length. You'll see what I mean. Okay, let me get my red marker right here. Let's say this is what we're dealing with right here. How much would we say? It's like 150. So we'll say that's 100. You might be wondering what this is. How to get there. Why is it there? It did it again. It cut off the video in the middle of me talking, just interrupting my lecture. And I'll have to restart. I would copy these down because I'm not going to rewrite them back up there. Copy these down. I'll give you a minute or so. Get a loose piece of loose leaf. Write all these down. And I'll have to reteach you arc length. Annoying, but I'll give you a good 20 seconds or so to copy those down. Is my head in the way? I'll do this. I'm too annoyed. I'm too annoyed. I had to redo it again for the same reason. At least it's only like a minute I lost out on. These are important. Write these down, write these down, write these down, write these down. Okay, you should have had enough time to write these down by now. And I would get up out of my chair, but it's kind of comfy, honestly. I should have done this the entire time, is just have a chair here. So if you had not written those down, you can rewind, rewrite those down. We're going to teach you length of arc. Formula is divided by 360 is the degree of your arc times your circumference. Let's put this into their speaking terms here. Let's say your
You point in the middle. Your diameter is,
Say a number, somebody say a number, please.
I don't care, 21 inches. It's 21, no, I've done, it's 21 kilometers. Okay, now,
Let me get my red marker out. Actually, let's get blue this time. Going blue.
here we go. From there to there. Now that arc, let's say that arc is 150 degrees. 150 degrees. That would be your X.
And you might be wondering, wait, but we don't know circumference yet. And you would be right, my friend. You would be a smart cookie, too. What you got to do is solve for your circumference, because you don't know it yet, right? But it's pretty easy, because it's just diameter times pi. Plug that into your calculator, please, while I do the exact same with my calculator here. Okay, let's see. Sliding all around here. It's sliding. Okay, there we go. Oh, shoot, it's off. 21 times pi. And you should get, by the way, I'm using pi, not 3.14. I've said it a million times, but if you don't listen, you're not going far, I'll tell you that. You should go like 65.97. You might be wondering, what happened? It did it again. It did it again. And now I have to redo this. Luckily I didn't erase it all, but let's just get going. So after you get 65.97, multiply this by 150 because that's your degree of arc. My calculator over here. I'm gonna need that. After you do that, you should get 9,895.5, and don't forget you got one more step, and that is to divide it by 360 degrees. Okay? Well, you can't put a degree, just 360. Okay? And so click divide by 360, and you should get no, wait, give me a second. Divide by 360, and you should get 27.48. No, I'm just kidding. You should get 0.49 because you have to round up. Don't forget to round up. Read your directions unless it says don't round up. Okay, you always forget to read your directions. I'm just saying for this particular lesson, round up, including for your practice answers. Okay. Practice questions. Okay, and then the unit of measurement, that should be your arc of length right there. Best of luck to you, and you know those questions I made you write down earlier? Those are your practice questions. Do those, and after this you should see me you should see the answers up here. You'll get a review of the answers, and those answers will be coming up. Pause it here, by the way. Pause it here if you haven't solved it yet. The answers to those questions are going to be up on this board, and I would say about 5, 4, 3. Remember to pause it. 2, 1. Easy. There you go. I'll give you like a second to check your answers, and while you're doing that, I'm supposed to, wait, what am I supposed to, am I missing something here? Let's see. Oh, I'm supposed to give real world examples and fun facts. It isn't fun, but you'll have to solve for area. Like, let's say you're building, I don't know, what's something that you would build? What is that noise? Let's say you're building
Might be my cuff. Let's say you're building a gazebo, circular gazebo, right? And you need to find out how much would you need to buy to fill the floor of said gazebo. You could solve for it you could solve for the area of it by figuring out how many feet it is across, then using that. See, it's helpful. That's how you know how much wood you'll need to buy if you need to build your theoretical gazebo. That's your real world example right there. And to all of you all, thank you for listening to me talk about this for like 25 minutes. If you made it this far, congratulations, because I sure as heck didn't. Bye-bye.